Now, finally, we are able to demonstrate the Noether theorem. This is B part 4, lecture 17a. Now, for a field theory where the Lagrangian is a field, attention now, Lagrangian is a field, okay, is the Eulerian viewpoint. L is function of phi. This is upstairs index A. This is derivative. This is the space-time x mu. We will follow a systematic derivation and then the theorem for the special case A is equal I is 1, 2. Now, let's start. Let phi A of x be a set of fields indexed by A, defined of the space-time coordinate x mu. Just for you to understand, you see, for example, for the special case of Cartesian coordinates, the space-time is x, y, z, and t is the dimension, the fourth dimension. And the action B, you see, S is the action acting on this field phi. This Lagrangian is a function of phi A, the derivative, and the space-time dx4. That's the action, okay, act on this field phi. Now, suppose the action is invariant on the continuous infinitesimal transformation. Attention now, invariant symmetry. Symmetry is a necessary condition for Noether theorem leads to conserved quantities. So this is for of the fields and phi A. You see, this is a Taylor expansion till the first order Taylor expansion of the field and of the coordinate x mu vice delta x mu. We will assume the transformation is parameterized by a small real parameter, epsilon, and consider the variation of first order in epsilon. You see? Now, the variation of the action. The total variation of the action on the sub transformation. You see delta S. This is S over here. You see? And this is delta S. Now you just apply the variation. You see? This L prime, X prime here, and this L of X. So this difference is the variation of the action S. To compare in the same coordinates, I'll just expand X prime in terms of X using Taylor series. So we use also the determinant to the first order in delta x mu. The determinant is Jacobian, okay? You see. So the determinant of this x mu plus delta x mu, the derivative with respect to x mu, is 1 plus derivative of delta x mu. Then you prove the next lecture, 17b. You prove like this relation. And then continue the derivation of Noether theorem.